Today we're going to look at a new formula for the area of a triangle. So we've come across quite a simple formula for an area of a triangle before. We'll just get a couple of triangles drawn. So our usual formula for the area of a triangle we learned a long time ago, hopefully, and that is your half base times height. So let me just connect this up. And remember, when you're doing this, the height must be perpendicular to the base. So this distance here, this is the height. It must be, get the ruler out of the way, it must be the vertical height, and that means it must be at right angles to the base. So if that's the height, then the base is along here at right angles to it. And the formula that we know is area equals a half times the base times by the vertical height. I'm going to introduce you to a new formula today. This one can be used on any triangle as long as the base and the height are perpendicular. So you might, for example, be given the distance there through the middle of the shape like that. As long as the base and height are perpendicular, then that will work. But you need a right angle. Okay, this has to be 90 degrees in here, otherwise the height can't be perpendicular. So they must be perpendicular. Let's have a look at a different triangle and our new formula. So a different triangle. Again, the orientation doesn't matter, as long as it's got three sides to the triangle. Get this lined up. So for a triangle like this, again, we're going to call the corners ABC, which you'll be used to if you've watched the sine and cosine rule videos. To find the area of this triangle, if we label it in exactly the same way as usual, so we have opposite our angle A, capital A, we have little a, opposite big B, we have little b, and opposite big C, we have little c. Then the area of a triangle is also given by a half a b sine c. So a half times a times b times sine c. So what you'll notice here is hopefully that you have a and b are two sides. So here's a, here's b. If you have the angle between them, then you can work out the area. It's quite similar to how you use cosine rule to find a third length. We could use cosine rule here to find C if we've got A and B. If we've got two lengths and the angle between them, we can always use this formula. So it might be that it's that way around, or it might be that we've got, rather than the angle C, we've got the angle B. If you've got C and A and angle B, it works the same way. So we could have a half AC sine B, or if we've got the other lengths, oops, sorry, the rubber's stopped working. There we go. If we've got the other lengths, so let's do this one in red. If we have B, not in red maybe. If we have B and C and this one, then the area of the triangle would be a half BC sine A. So it's always two lengths and the angle between them. You can use this formula whatever orientation the triangle is in.